Inequalities and their graphs is our first lesson in chapter 3, where we will be looking at graphing and solving inequalities of different complexity. So the first thing we should cover is inequality symbols. So we have 4 different types of inequality symbols that we'll be looking at. Our first symbol here is a less than symbol, assuming that x is on the left side of our symbol. Our second symbol is very similar to the last, although this one has a bar underneath the symbol. This indicates equal to. So this symbol would be a less than or equal to symbol. Okay? Our next 2 symbols are just the opposite. So our next symbol would be a greater than symbol, with our last symbol being a greater than or equal to. Okay, so those are our 4 types of inequality symbols. The solution of an inequality is any number that makes the inequality true. Okay, so if we have our example, x is greater than 2, this means that any number greater or larger than 2 makes the inequality true. Okay? So in our next section here, we are going to substitute values into a couple different inequalities to kind of see how this would look. So determine whether each number is a solution to the given inequality. So for these examples, we are going to substitute the given values into our inequality to solve to see if it makes a true or false statement. So for example A, let's substitute 2 into our inequality by replacing it where we see our variable y. Go ahead and solve. 3 times 2 gives us 6, minus 8, greater than 22. This will leave us with negative 2 is greater than 22. Obviously, negative 2 is not a larger number than 22. So this makes 2 not a solution. Let's do the same with 0. We have 3 times 0 minus 8 is greater than 22. Obviously, 3 times 0 is 0, so that gives us negative 8 is greater than 22, which is also not a true statement. Finally, let's substitute 5 into our equation. So that gives us 3 times 5 minus 8 is greater than 22. That will leave us with 15 minus 8 is greater than 22. 15 minus 8 gives us a positive 7 is greater than 22. 7 is not larger than 22, so this is also not a solution. The one thing you may be able to tell is as the value that we are substituting into our equation increases, the closer we are getting to a true inequality. So we can infer that if we substitute an even larger number than 5 into our inequality, that we would start to get solutions. All right, on to our second example here. We have 6 minus n over n is less than or equal to 11. So let's substitute in 0.5. 6 minus 0.5 over 0.5 less than or equal to 11. So let's go ahead and simplify our fraction. So 6 minus 0.5 gives us 5.5 over 0.5 is less than or equal to 11. 5.5 divided by 0.5 gives us 11. So that gives us 11 is less than or equal to 11. This is a true statement because these two values are equal. So yes, 0.5 is a solution to our inequality. Next, let's substitute 2. So that gives us 6 minus 2 over 2 less than or equal to 11. 6 minus 2 gives us 4 divided by 2 is less than or equal to 11. 4 divided by 2 gives us 2. And yes, this is also a true statement. 2 is less than 11. Okay, for our final substitution, we have 4. So we have 6 minus 4 over 4 is less than or equal to 11. 6 minus 4 gives us 2 over 4 is less than or equal to 11. We could simplify this fraction to be 1/2, which, yes, 1/2 is less than 11. Okay, so that is how you test solutions of an inequality. All right, on to graphing. So when you're graphing inequalities, you will have an open circle or an open point. This indicates this number is not included in an answer, and it indicates that we are using our less than or greater than symbols. A closed circle indicates that the number is included in the answer, and we would use less than or equal to or greater than or equal to symbols. Okay? An open point will look something like an O or a 0, while a closed point will be filled in. Include at least 3 numbers on your number line. Careful with negative numbers. Okay? Make sure you also write these numbers from least to greatest, as that is how a number line is structured. Okay? One graphing trick before we go on to some examples is that when a variable is on the left side, we will shade the direction the inequality is pointing. If the variable is on the right side, then we cannot follow this graphing trick. It will not work. Okay, so let's go on to a couple of examples of graphing. So our first example, n is less than 1. Yes, our variable is on the left side, so we can use our graphing trick. So on our number line, let's plot 3 points. So I'm going to start by plotting the point that is in our inequality, which is 1. And now I'm going to plot a point that is greater than 1. So I'll plot a 2. And I'll plot a point that is less than 1, which can be 0. So since we have just a less than symbol, we are going to use an open point to designate that it is not part of our solution. And since our inequality, or since our variable is on the left side of our inequality, we can go ahead and shade the left side. Also, read the inequality. N is less than 1. Obviously, the side with 2 is greater than 1, so we have to shade the side that is less than. Okay? On to our example with -3 here. We have -3 is less than f. If we would like, we could go ahead and rewrite this so that f is on the left side of our inequality. F is greater than -3. Okay, this will help us with our graphing process. Let's go ahead and plot 3 points. We have -3. Remember, -2 is greater than -3, so that can go on our left side or our right side. And -4 is less than -3. So since we just have in our new example a greater than symbol, let's go ahead and use an open point and shade the direction our inequality is facing. All right, good. So in our next two examples, we have a greater than and equal to symbol. And then in our last example, we have a less than or equal to symbol. So same process here. Let's start by plotting our points. We have 0. Use the same color here. A value that is larger than 0 would be 1. And then a value that is less than 0 could be -1. So let's plot our point at 0. In this case, we will use a solid point. And now, since our variable is on the left side, let's shade the direction that the inequality is facing, which would be the right side. A is greater than 0, so we are going to shade the side with the greater values. Next, we have -2 is greater than x. X is on the left side, so we can go ahead and rewrite this. X would be on the left side. We have x is less than or equal to -2. This will help us know that we have to shade to the left. So let's plot our points. We have -2. A value less than -2 would be -3. And a value greater than -2 would be -1. Be super careful when you are plotting these points on your number line, as the negatives can be tricky. So let's plot our point at -2. This will be a closed point, and let's shade to the left as that is the direction our inequality is facing. So those are a couple of basic examples of how you graph inequalities. Let's look at how to write an inequality from a graph. So I know these three graphs may be a little bit difficult to read. Our first one here, we have a solid point at 8, shaded the positive direction. So for all of these, let's set it up so our variable is on the left side of our inequality. We have a solid point, so we know that it has to be an equal to symbol, and it's shading to the right. So our inequality will point to the right. The point at which our closed point is at is 8, so that is what will be on the left side of our inequality. Okay, very similar process with the next example at -0.6, although this one has an open point. So let's start by writing our variable on the left side. We have x, you could use any variable for this. We are shading to the right, so we must have our inequality point to the right. Remember, open point, we will not have our equal to symbol. And then write our value at which our point is at, which is -0.6, or -3/5. Our final example here, we have an open point at -9. Okay, so let's start by writing our variable on the left side. We know that we are going to shade to the left, so we will insert a less than symbol. This will not be equal to because it's an open point. And now state our value at which our point is at, which is -9. Okay, so I know this is a lot of new information. We will make sure to practice a lot in class and make sure you bring a lot of questions. Thanks for watching.